Hi, my name is Eduardo. I'm a front-end developer and a member of the VGS core team. And I live in Paris, where I used to organize a VGS meetup, but now with COVID, there is not that much going on. I maintain a bunch of Vue libraries, and among them, I created the router, the official router for Vue. So you might have used some of the things I do, and I try to spend most of my time doing open source. So the router, the Vue system, anything I can touch to, but I still work a little bit on the side as a front-end freelance. And today, I want to give you a very different talk from what I usually do. Instead of going deep into some of the technical details of the router or very Vue-specific things, I want you to give some practical tips and tricks that you can use on Vue 3 applications. So some of these tips also apply to Vue 2 applications using the composition API. But most of them are very specific to Vue 3, like new features that you won't find in Vue 2. And it's quite easy to start by talking about the composition API, right? Because this is the thing that is really new to Vue 3, even though you can have almost the same on Vue 2. But there are a few things that are not always talked about. So when you think about composition API, you're mostly thinking about these things, right? The ref, reactive, compute, watch, all the life cycles like unmounted, unmounted, or destroyed in Vue 2. And then we also have these provide inject, which existed in Vue 2, but were not as used as they are in Vue 3. And in fact, when we look at these things, there is so much more to cover, and so many of the things that we don't really use that often, but some of them are very, very useful. And I won't be talking about all of these composition APIs because we have a great documentation that explains all these things for us. But there are a few things that I want to give you some examples, and I want to go over them a bit deeper. And more specifically, I want to focus a little bit on the ref sections. So one function that is very, very simple that you might not have used before is unref. Now, unref is a one-liner in the code source. Is basically allows you to treat references and regular values as the same. And this is the most basic usage you could find. So you have a reference, so counter ref is a reference of a number, and the counter is just a regular number. And then if you call unref on any of them, it will yield the actual number. It will unwrap any reference, and if it's not a reference, it will just give you the value as is. It's really a one-line function. Now, the reason this is actually useful is not in a scenario like that, but more if you're creating composable functions, or if you have functions that are gonna be used inside your components, and they may receive raw data at the same as reactive data, and you might want to just be able to handle both scenarios at the same time, not only the raw data, so you don't have to write the value, but also reactive values. But where they really shine is with composable functions. So imagine we have this use interval function that we are going to create. So it allows you to set up a handler, a function that is going to run at a given interval of time, and you wanna call this interval only on the client side, because remember that there is no destruction, so there is no unmounted on the server side, so you will never clear the interval and create a leak. But so that's why we have the unmounted and the unmounted and unmounted. And the way we use this is by passing the handler to use interval. In this scenario, we're just gonna log in the console, are you there? And we're gonna do this every 1 second. Now, this works nicely, but very often we might want to pass reactive value. So let's say we want to pass an interval time that changes over time. Like for example, this interval time variable that we pass to the use interval. Now, if we do this, we have to also update the use interval function. And we can do this by simply wrapping the read of time with unref. Now, in this scenario, it will work with both regular values, raw values, and reactive values. And of course, this is not done because we also might want to watch these time just in case, but we're going to go a little bit further. One of the questions that rise for people is the TypeScript that we might need for it. Now, I'm not going to dive too much into TypeScript because not everybody uses it, but just so you know, you can just type very easily these functions, these parameters, and most of the time you're just going to create a type, a generic type, maybe ref, that is just going to be a ref or the type itself. This is especially useful if your parameter can be multiple types. If it's one type, writing ref of number or number is not a big deal, but otherwise it gets really messy very quickly. So this is not all we want to do. So imagine we want to also make the handler a ref. So we can use the maybe ref for the handler as well. And then we can update the code so that we can use that new function if it changes, and also change the interval if it changes. So we can change the code a little bit by adding a watch effect. Watch effect is just like watch, except that we don't provide all the dependencies, all the things that we're watching, because it's going to watch anything that we access inside. So we unwrap the handler as well inside, and we unwrap the time inside. And because this is going to read the dot value of the reference, is going to make the watcher depend on these values. So if any of them change, this function that we pass the watch effect is going to get triggered again. And what we do is we clear the interval that we had before if we had any, and we set out this new interval again. Now, you might be wondering, what if I want to make a different scenario based on the ref, based if it's a ref or not? There is a very small function that is actually used inside Unref, and it's called isRef. And most of the time, this is not a big deal. Like in this scenario, I would just go with the Unref in all the cases and set up the watcher anyway. It shouldn't be a big deal. But in some scenarios that involve more computational logic that can be heavy, or you want to compute logic on big objects, big collections, then you might want to avoid setting up the watchers or all the things, because it can consume more memory. And these can be a problem for big collections as well. So this isRef is handy in these scenarios where you can specify different conditions and make sure that you avoid these extra computation that you don't want. Now, to summarize very quickly, because just to show you that this is one of the simplest thing, but that so many people don't know about, is that Unref allows you to unwrap refs as well as non-refs, also regular values. isRef allows you to toggle between two versions of your code that may be specific for reference and other for normal values. And the TypeScript support is very, very easy as well, because the composition API was built with TypeScript in mind. So if we go back to this list of things, there is another thing that I want to talk about, and that is custom ref. But before talking about custom ref, I want to give you an example of a computer property and talk about some keywords that we're going to use. So in this example, classic one that we have in the documentation for Vue 2, we have a full name that is based off a first name and a last name. Now, the full name only adds a space in between. But when the computed is called on this function, on the first name value plus the last name value, we're going to track that first name reference, right? The full name is going to be tracking the first name. And because we also call last name, we're also going to track the last name. So that's going to tell last name and first name that they have some kind of subscribers, to simplify this idea. So both of them have one subscriber, and that subscriber is the full name computed property. Now, what happens later is that if we change the first name, we're going to trigger the reference. We're going to tell the reference, hey, you're different, so you should better notify your subscribers. So that's what it does. It notifies all the subscribers to tell them that they should reevaluate again. Now, in all these keywords, all these three keywords, or subscribers if you want, that's four, we only care about track and trigger, because those are the actions. Those are the parts that are made automatically by Vue. I'm oversimplifying a little bit, but those are the parts that are made by Vue to make the reactivity work out of the box. And the idea of a custom ref is to get access to those low-level functions, so we can call them ourselves and get the hand on when the reactivity triggers. So those are the two things that we're going to get when we call custom ref. We pass in a function, and in these functions, we're going to get to decide when to track and when to trigger the ref. So for example, trigger is going to make your template render again, whereas track is going to subscribe and is going to connect to the trigger. The trigger is going to notify all the subscribers that you tracked. So how does it work? Imagine we want to create a debounce reference. So these will be a variable that can be changed, but will only notify the subscribers after a delay, since it hasn't been touched. So I'm going to give you a practical example just later. The idea of custom ref is to return in that handler, that function that we passed to it, we have to return an object with a getter and a setter. Now the getter is supposed to read the value, and most of the time you're going to track in there because that's when you want to say, okay, we have subscribed to this reference. So this is the simplest custom ref, the simplest getter you can have for a custom ref. We just track and return the value. And the value here is given by the parameters, which is going to contain the initial value of this reference, is the bounce reference. And then the setter is going to get a new value. And what it's going to do is, if we skip the clear timeout and the value new value for the moment, and we focus on the set timeout, it's going to delay the call-off trigger until, in this scenario, 200 milliseconds by default, but we can customize that. And I also use that Unref just in case the user wants to change that value. Now, one important thing to note here is that I'm setting the value anyways. So I'm not waiting the 200 milliseconds to set the value. And also notice that we clear the timeout beforehand. So if we were waiting before, we're going to stop that one and start a new one, because that's the point of a debounce. If we're going to type, for example, in a search, which is going to be the example I'm going to use, we want to wait until the user has stopped typed before triggering a watcher or any other computation. Now, the idea here is that by setting the value before setting the timeout and not inside of the timeout, we're still going to be able to retain the actual value, even though it hasn't notified all the reactive things. So I'm going to show you an example of why that's important. Now, the most practical example that I was talking about is searching. If you have a search that works when you type, for example, in documentations, in Argolia, you might want to get some kind of combination between throttling and debouncing, so you don't trigger too many API requests, because there is no point in triggering one request per character type in the search box. That's going to waste a lot of resources for your application. And if you have some rate limiting API, that's going to be some trouble for you. So imagine a scenario like this where you have these search tags and we use a debounce ref that we just built, and we're going to watch it, and then we're going to just trigger an API. So then if the user is typing, imagine they start typing the, for example, and they have a small break because maybe they look at the keyboard like we all do. And then they finish by typing the end of the word. So they meant to search the ring. Then if we wait another 200 milliseconds, we're going to get in the console an array of movies that match that search. I'm going to get the ring and all of the rings. But we're only going to get one console log, and that's the important part. We don't want to get any other log in the middle. So I'm going to give you an example of how this works and why it's important to have the value set differently. So here, what I have is the delay of 200 milliseconds, and here is the computer version in uppercase. And you're going to see that if I type very quickly, it only happens after I stop. Now, what I have under here is a version that is forced to recompute every 1,000 milliseconds. So it's a copy of this one, basically. But no matter, basically, I'm triggering a render, forcing a render every 1 second, so I can see if I'm typing something. And as you can see, every 1 second, no matter how much I'm typing, I will see the value update. And only 200 milliseconds after not typing anything, I will see the value update here. If I reduce the timer here, for example, to 0, I would just get the same value all the time. I mean, it's completely synchronized. Now, the problem is more in 1 second here. So I have these text, change me, and right now I'm using the version I showed you with the setting of the value outside of the set timeout. Now, if I do it inside of the timeout, you're going to see a little bit different. So if I start typing, you're going to see that I lose a few of the character. Now, this is the best way to see this is by keeping one key press. So what happens here is that while I'm typing, I'm not updating the value, the internal value held by these. But if I'm rendering again, I'm using that value to display the vModal. So this is something that a lot of people have come across with debouncing specifically, and having these custom ref with the value set outside of the timeout and having this low-level control gives us a possibility that we didn't have before. So that's really great. Oops. OK, if we go back to the composition API, There are a lot of the functions here that we see, and most of them that we use. So to name a few, we have ref, reactively computed, watch, and watch effect that are bound to what we call the lifespan of where they are called. So for example, most of the time, we're going to call these functions inside of the setup of a component. Now, because we call them inside of a component setup, they're going to be bound to the life cycle or the lifespan of that component, which means that once the component is destroyed, there is no more watcher going on, which is the whole point. Now, this is a problem if you're trying to do global lazy stores. So with the new composition API, you might have heard that you can create your own store. You don't need Vuex anymore. And it's true, you don't need Vuex anymore, but you still need to be careful. That's why we still have Vuex5 and other things like Pina. So most of the time you want to create the store lazily. So this is an example where we hold the store outside of a function to make sure it's global. And the first time we call the function useStore, we're going to create the state, we're going to create the computer, the watcher, and we're going to set that. We're going to save that store somewhere, and then we're going to return it. So this way, every time we call useStore, we're going to get the same store. It's only created the first time. Now, the problem with this approach is that if we call this function useStore inside of the component for the first time, then it's going to be bound to that component, meaning that if that component is destroyed, we lose all of reactivity. So you might be thinking, okay, well, I just have to move the call of the user outside of the component. And that's true, that will work out, except if you're doing server-side rendering. Because in that case, you're going to be sharing the store for all the requests, and that's going to be a problem. So if you're not using server-side rendering, fine, go with this approach. It works flawlessly. It's really nice. But otherwise, we have to stick to this approach, and we're going to have to find a different way of doing it. Now, I want to show you the actual bug that I'm talking about. So here we have a store in a page. And so basically, I have a counter on the double. And if I increment the counter, I can see the double update here. All great. Now, imagine I move somewhere else, which means that my component, my counter, gets destroyed. And then I go back and return. I can see still my counter holds the previous state, which is perfect. It means that it's global. We were using the same store. But if I increment, I'm going to see that only the counter changes. The double doesn't change anymore. So that's a problem, right? Because all the reactivity was connected to the counter component. Now we don't have it anymore. So it was lost, and we're not recreating every time. So what do? If we use a different solution, so this is a different store, if we increment and we go somewhere else and we go back, we're going to have the correct thing working. We switch back to the broken one. It's never going to work until we reload the page. And in that scenario, then, yeah, it's going to work again. But the other one works in all the scenarios. Going anywhere, it works. So how do we handle this? If we go back to our code sample with the state inside of the useStore that is created and being connected to the component lifespan, what we need to do is to disconnect that reactive state, that state that outlives the component, because that's the whole point of a store. We should have a state that lives outside of the component tree. So we have to remove that from within the lifespan of the component. So we have to make sure that it's created outside of the useStore function. And one of the easiest way to make sure that it also works in server-side rendering is to use app.provide. So we provide something at the level of the app. Here I'm using my state as a key, but most of the time I recommend you to use a symbol to not collide with anything else. And then I'm just passing this reactive state like that. I could also hold it in a variable and export it somewhere. That doesn't really matter in this. This is just to simplify. But the whole point is that later on in the useStore, I'm calling inject. Now, there is one thing to know with inject is that it's only going to work inside of a component. So it's a bit more complicated if you use it outside of components this time. But there is a way to handle it. And then the thing is, we are still keeping all the computed and all the watcher creation inside of the useStore. So the idea is, if useStore is called inside of a component, the computed properties and the watch effect and the watchers are all bound to the component lifespan. So once a component is destroyed, these computed and these watchers are discarded, and they can be garbage collected. Whereas the state is not, because that's the part that is global and stays alive the whole time. If you're interested in this approach or seeing something, an implementation that does that, take a look at Pina, which is a type-safe store implementation that was based on the composition API, and that works for Vue 2 and Vue 3 with DevTools support for both. And it has inspired Vue 5 anyway, so you will likely see somehow the works of Pina out there. And also, if you're interested in this lifespan concept, take a look at the proposal by Anfu for FedScope, which is meant to precisely deal with this problem of, hey, I'm creating these things inside of a component, but I don't want them to be connected to the lifespan of the component. I want to get a handle of that lifespan as a whole entity. And so completely changing topics, I'm going to talk about a very practical thing that I see very often that you have done for sure in your SPAs, your single page applications, is data fetching. Now, data fetching, it's a very large concept because you can do so many different things, and the idea is to allow, from the router and Vue perspective, is to allow the users to do to be able to do all the different things that we can do. So we have to provide sometimes very low-level APIs that can be redundant, and that sometimes you have to build things on top of it to get a common logic inside of your application. So in Vue Router, you might have seen the before route enter. These navigation guard triggers before entering a route. Now, because it triggers before entering the route, it happened before the component exists, before the component is mounted. That's why we don't have access to these inside. So for example, I don't have access to the memes array that I can see in data there. And so imagine I'm entering these meme lists, so these lists of memes, and I want to fetch the memes, and then I want to set them in my array. So I have to do these. I have to do it one time. It's okay, but it's still weird. It doesn't feel all right because we have this callback pass to next. It's not that great. Now, the problem really shines when we introduce some page with a parameter. So imagine whether we can click on the meme and get some details and some history on the memes and some examples, some related memes, whatever. Now, you have this data that you initialize to null. So this meme is null. And the problem is that before I enter, when it's called outside, it's called before the component is created. And the call that we give to next is called after the component is rendered for the first time, meaning that we have to handle that null case scenario inside of a template with a VF or whatever you want. Most of the time, it's just a VF around everything. We can create some flashes and stuff, so it's not perfect. And on top of that, if we want to reuse the same component, which is the default behavior, so when we change for example, we go to, I don't know, /memes/23, we go to 24, we're staying on the same route. The URL is changing, but before route enter is not going to trigger unless we put a key on the router view. So we need to also handle that with the before route update, which in this case, we do have access to the component because the component is already existing. So we can do these.meme equals whatever. Now, if we don't want to have these, because in this scenario, we're duplicating the logic a little bit, we have to add a key to the router view component. Now, that works, but if you have some very heavy computational things, or you have a very big page, recreating the page every single time is going to be visible. So if the user goes from one page to another very quickly and the pages are very heavy, that's not going to be a good thing for the UX. So you want to reuse the component. And we give you the opportunity by default to reuse the component. It's just that you can use a key to simplify some of the parts of the code if you don't care about the page heaviness, which most of the time you don't care, to be honest. So most of the time using a key is something that works. But here we're going for a perfect solution to say, so for something that is more works in all scenarios, so also the heavy ones. How can we improve these? We can improve these by using meta. Now, meta is not used enough, I would say, on the router. It's a very powerful feature. It allows you to associate anything to a route record or to a route. So for example, we can add a function to this route with the memes. And we can say that we have a function that takes in the params, only use the meme ID, and then fetch the meme. And then we combine these with a before resolve hook. And so we're going to check if the fetch property exists in meta. And if it exists, we're going to take that information and put it into a data property in the meta object. And you might be wondering, what is this before resolve, or why specifically a before resolve? Before resolve is like before each. It executes with every navigation, but it is at the very end of the navigation card chain, which means that if there is any other problem beforehand, you're never going to fetch your data. You're never going to waste an API call if you know that the user cannot access the page, for example, because you're going to do that in a before each, which happens much before that. If there is an error retrieving the component, you're also not going to have the problem. So that's why we combine before resolve with meta very often. And then if we come back to the component that we had just before, we're going to drastically refactor these. We're going to remove almost everything, and we're going to have only a computer property that is going to read that data property from meta. And you can use these in any other component that does the data fetching. So that's it. And then you don't have the situation where when you have one tick, one render that happens without the data is always present because you made sure that you had it beforehand, and you're reading these from the meta property. Now, the meta property, you can do so many things with it, so many. Here's another few examples. You can set the title based on the route. So you can, for example, now that if you fetch the meme, you can use the meme name on the title to whatever you want, and change it in a router before resolve. And you can also set a dynamic transition. This is especially nice if you have some pagination in a search, so you can have going to the right or the left. And all of these is because in Vue 3 with the Vue Router, you can attach anything you want to this meta object. The reason is because now the meta object is created in every single navigation. So anything you add to it is going to be held during the navigation. It's not like history state. It doesn't stay when you go back and forward, but that's why we use before result, because it's going to trigger with every single navigation. So we make sure that you're going to get a new version of it. So if you want to check the demos that I was showing, there are a few other things, small things. That you can check the online demo at this first URL, and the source code can be checked in this repository. Before finishing, I want to thank my sponsors. So I have starting to get a lot of sponsors. I'm really happy, very grateful for it. It's really helping me out to reach that 100% time open source. And I want you to know that if you want to become a sponsor, you get access to some advanced content like the one I'm showing in this presentation, and also some videos for more long content in my only sponsors. And that if you want to sponsor me with some higher tiers, you also get exposure through some of the repositories like Vue Router and its documentation, which has more than 1 million page views per month. So that's an interesting way for me to be able to keep working on open source and making a living out of it. Thank you.